Hello and welcome back. This is Greg French. Today we're going to look at subnetting Class C addresses. And we're going to take just one bit from that last octet. So we're going to use the /25 to show you that we're using 25 bits, not 24 bits, where you'd have a standard Class C IP address. But we're going to subnet the Class C. We're going to actually divide that last octet. So we're going to get 126 hosts to be able to assign one network and then another 126 to a second network. So it's just about dividing that last octet in half. Gives you two networks instead of just one, just by taking one bit. You can see by this little diagram, this is a packet tracer diagram. We have a network between the PC and that first router, and then we have a second network between the two routers. The first network is 192.168.1.0. And our second network is 192.168.1.128. When you first look at this, you might think that all these IP addresses are on the same network. We start off here with 192.168.1.1. We have a 190 or a 129, a 254, and a 126. But if you look at the subnet mask down here, we got 255.255.255.128. Different subnet masks. Normally this 128 would be 0 in that last octet, and that would be a typical Class C classable address. But we have taken and added or borrowed a bit or added one more bit for our network portion. Changes that 0 to 128 because we set that last higher order bit in that octet. We do that, that last octet becomes 128 instead of 0. But that also tells the computer that we have one more bit to consider when we determine networks. And that bit can either be 0 or 1. If it's 0, we get this address here, 192.168.1.0. And then if we set it high to 128, we get the second network, 192.168.1.128. So that gives us two separate individual networks that we can use for setting up routers or a small local area network where we need more than one router. So let's get started here. I'm going to go back to just a typical Class C classful address where we have a typical subnet mask or default subnet mask of 255.255.255.0. The /24 up here represents that there's only 24 bits in the network range, and that's represented by these three 255s and these first three octets. So we have 8, 16, another 8 is 24. The last octet of 8 is all zeros. And the zeros in the subnet mask represent our host range. So that gives us from 0 to 255. We don't use the 0 because that identifies the network, and we don't use the 255 because that identifies broadcast. That leaves us 254 hosts that we can assign in a typical Class C network. And what we want to do is borrow or get this one bit. They talk about borrowing one bit or adding this one bit to our network side by setting it high. The subnet mask will change from 0 to 128 when we do that. It only leaves now 7 bits that will be 0 that we'll have ability to assign to different hosts. But that's still 126 for the first network and 126 for the second network. So down here at the bottom, I just have a typical 8 bits from 128 to 1, showing that the value of each of these bits double. That's a power of 2. So we go from 1, 2, 4, 8, 16, 32, 64, and 128. And if all of these were set high, we would get the 255. Looking at this, we have that if we look at our last octet in this Class C, again we have 0 as the starting, and then if we settle these high, it'd be 255. Again, the 0 is reserved for network, and the 255 is reserved for broadcast. So that only leaves us 1 through 254 assignable to different hosts or devices that need IP addresses. Now, when we subnet, we're taking bits from this last octet in the range. And this time we only take the 1 bit, and we take that 1 bit, which is the first high order bit. It's 128, so that sets our subnet mask from 0 to 128, showing to the computer, showing to devices that this bit here, this high order bit 128, is now considered network. So we only have these last 7 bits that are considered for hosts. So our range now is only from 0, we have them all set 0, to 127. If we set 64, 32, 16, 8, 4, 2, and 1, we would get 127. That's one less than the next higher order bit, 128. So that leaves us, if we take away the 0 and the 127 for network and broadcast, 126 assignable IP addresses that we could use for computers, hosts, devices, whatever. So 126 on this one. Now we're going to set this bit high, and we still end up with another 126. But when we set that one high, our values now are increased by 128. So our first assignable IP address in this range is going to be 128 plus 1, or 129, because the 128 with all of these hosts set at 0, this host range, that gives us the value of 128. And that's our second network. So we can't assign a network address to a device. We have to reserve that for network. So we start assigning our devices with the first available, which would be the 128 plus 1. So it becomes 129, and it goes all the way to 254. So again, we have 126 assignable IP addresses that we can assign to computers, hosts, nodes, whatever device needs an IP address. Next, I just want to look at, we got, again, the two networks now. 192.168.1.0 when we have this set as 0, 128 set at 0. And then when we set that 128 to 1, these are our only two combinations for that one bit. The next network becomes 192.168.1.128. And here you can see our subnet mask that we use for both of these networks. And it has that 128-bit set, so the subnet mask changes from 0 to 128. And this is used with both networks. And again, you can see we still have our host bits all set with 0, and we can assign hosts any of the available IP addresses in that range. Now here I've set up this network. It's in a packet tracer. And we have a network here, the 192.168.1.0, and then the second network up here, 192.168.1.128. And we've assigned 1.1 here for this router for the default gateway for this PC, and we've assigned the PCA 126. Then over here we've assigned 129, which is in the range for the second network for the serial port for this router. And then we've assigned the last IP address in that range, 254, to the other serial port on the other router. Again, here you can see our subnet mask, 255.255.255.128, and that is used for both of these networks. If we're going to go ahead and test this, first thing we're going to do is go ahead and set up the IP addressing for the PC and then for both the routers. And then we can ping from this PC through this router to this router, and then we'll get that ping coming back and make sure we have a successful network setup. I like to use Packet Tracer as the device just to verify that the network that we've designed is functioning. So the first thing we're going to do is set up this first PC. We're going to assign it 192.168.1.126 for its IP address. Again, we'll use that subnet mask that we came up with, 255.255.255.128, and then our default gateway is that router port, 192.168.1.1. Next is we're going to set up that first port, which is an Ethernet port connecting the router to the PC, and we're going to assign 192.168.1.1 to its Ethernet port. That becomes again the default gateway to the PC, and again we're going to use that subnet mask that we came up with, 255.255.255.128. Next, we're going to look at the serial port on that first router that connects to the second router, and that IP address is going to fall into that second network range. The second network is 192.168.1.128, and then the first usable is 129. That's the IP address that we'll assign to that serial port. And again, we're going to use the same subnet mask that we created, the 255.255.255.128. Next is we're going to look at the serial port that this router is connected to on that second router. Now, before we do that, we're going to go ahead and set a static route in this first router. Static route is just going to be a default route for any packets. Since we only have two routers here, if packets are coming into that first router, we're just going to send them to the second router. And if packets are coming back or coming to that second router, we're going to send them to the first router. So we're going to set up a default route, and we're just going to assign all zeros to the network, all zeros to the mask. That's going to tell the routers anything coming in, we're going to forward it to this IP address here, 192.168.1.254. Now this IP address is called the next hop, and that's where this first router is connected to the second router. That's the IP address of the second router. So we're just going to click on add here, and that'll add this new route, this default route. Now on our second router, we're going to go ahead and set that IP address on that port that's connected to that first router. That's 192.168.1.254. It's in the same network, and we're going to use that same subnet mask. And again, we're going to have to set a static route on that second router, so any packets that it receives, it knows where to send them. It's going to send them back to that serial connection that's connected to on the first router, which is 192.168.1.129. And we set the networks and the mask to all 0, so it takes any packet and sends it back to this port. And we just press the add here, and we get this new default static route. And then if we ping from our first PC to that second port, or that port on the second router, again is 192.168.1.254. You can see the pings are successful. They go to that port, and then the port returns them back to the first router, then back to us. So this verifies that our network is working, both 168 or 192.168.1.0 and the new network 192.168.1.128. Both of these networks, since we've divided them from a typical Class C and created 2 networks just by borrowing 1 bit from that last octet. We borrowed the higher order bit. That higher order bit is set now, so our subnet mask becomes 255.255.255.128. It was 0, but now it's 128 because that bit is set. We have to set that bit, make sure it's set so that any computer or device understands that that bit is now considered part of the network address. And that's what allows us to set the 0 here, or set it high and get the 128 for the 2 separate networks. Hope this helps understand borrowing just 1 bit and creating 2 networks. Next, we're going to borrow 2 bits. And with 2 bits, we're going to find that we have 4 different combinations. They can all be set 0, or 0, 1, or 1, 0, or 1, 1. It gives us 4 combinations, so it allows us to create 4 networks. So I'll see you on the next one. Thanks very much for watching this. Bye for now.